Hi dear friends, today we will discuss about the verification and validation in continuation with the testing. So this is the another very basic concept, that means the verification versus validation. Verification is the process of determining whether the output of one page conforms to the previous page, whereas the validation is the process of determining whether a fully developed system conforms to its SRS documents. So the verification is done after the every phase just to check whether it conforms to the previous phase. We can think of the verification as the techniques for phase containments of the errors, whereas the validation is for the fully developed software. We check if the final product is the error free. What are some of the verification techniques? These are the review, simulation, unit testing, and integration testing. Just observe here that the unit testing and integration testing are the verification techniques because these are not done on the fully developed systems. The system testing is done fully on the fully developed system. Therefore, the system testing is the validation technique, where as the unit and integration testing are the verification techniques. We can make further distinction between the verification and validation. Verification, we check whether we are building the system right and that is not committing any errors. Try to detect the errors as quickly as possible. Whereas validation, we check that after the final things we have built, whether we had built the correct thing. Here in verification, we check the artifacts that are developed after a phase if it conforms to the previous artifact, whereas validation checks the final product against the specification. The verification activities are done by the developers, whereas the validation by the testers. Verifications can be static or dynamic activity. In static activity, you do not need to execute the program. For example, review is a static activity and we might have to actually run the program, and that is the dynamic activity. Unit testing is the dynamic activity, whereas the validation is always a dynamic activity. We execute the software and check against the requirements. Now let's look the testing levels. Software is tested at the four levels: unit testing, integration testing, system testing, and a regression testing. Unit testing, each time is tested each module or function. Integration testing, a set of modules is integrated and tested. The system testing, all the modules after integration, that is the complete system is ready. In regression testing, it is done during the maintenance and any bugs that are fixed need to do the regression testing. So unit testing, each module unit that is a function or a component that is independently tested, mostly done by the developers of the module, whereas integration and system testing are done by the testing or a quality assurance team, and acceptance testing is validation testing done by the end customer. From this diagram, we can see here that on the development side, we find what the user needs, get the requirements, then design and code finally. Maintenance and testing side. Unit testing on the code, integration testing on the design, and system testing based on the requirement, and the regression testing for the maintenance work. If we look at the testing activities that are done during the testing, one is test shoot design, running test cases, checking results to detect failures, and to prepare the failure list. And the test report is done by the tester, whereas the developer debugs and correct the error. Now let us have a few quiz. As testing proceeds, more and more bugs are discovered. So how do we know when to stop testing? This well said, there are two techniques. One is to check that the few days of the testing does not discover any new failures, and the second is by seeding bugs. Give example of the types of bugs detected during unit testing, integration testing, and system testing. In unit testing, we can identify the bugs in a unit of example. Logical errors. Integration testing, we identify the bugs that are at the interface of two modules. So here we identify the interface bugs. System testing, here we identify the bugs of example performance related bugs which are not identified during unit or integration testing. Now let us first look at the unit testing. Here the units are tested in isolations. The units can be functions or modules, but the question is that why not test all the modules together? Why do we do unit testing? The reason is that if we do not do unit testing, it would be difficult to determine which module has the errors in the unit testing. We are testing only a small unit and we know that the bugs is there. We quickly debug and correct. But if we do not do unit testing for each bug, we have to trace out which unit has the problem and debug it and correct it. So it becomes much more expensive. If we do not do unit testing, in integration testing we integrate few modules together and then check their interfaces if there are any problems. Now we will discuss the integration testing. In integration testing, we integrate a group of functions or classes, then find if they are compatible. If there are unexpected parameters values, on the other hand, the system testing, we look at the entire system. There is another term here, smoke test. Before we start to do a test, normally do a smoke test. Just imagine that a plumber has put a pipeline and before he actually puts a real water in that and test, we would like to see there are any leakage, and they do a smoke test, see if there are a leakage, they put smoke. And similar thing here in the software, in smoke test we just check if some basic functionalities are working and it does become test worthy. We have looked at some very basic concept in the testing, and we overall end of this lecture. We will stop here, continue in that next lecture. Thank you.